So have we ever wondered why neurological diseases like Alzheimer's and Parkinson's haven't been cured since being first discovered in the 1800s? That is partly because the nervous system has a very limited capacity to regenerate, but more importantly, there is just so much more that we do not understand about the brain. So that's why there are scientists like me who are trying hard to discover what we do not understand. I'm particularly interested in this process called S-acylation. So what is S-acylation? So if we look at these three sets of images on the slide, they all have one thing in common. That is their ability to switch from one state to the other. So with the superheroes, they don their superhero capes and suits, and they switch between their superhero lives and their normal lives to maintain the balance. And with the light switch, obviously, you turn it on when you need to see things and do your work, and you turn it off when you need to sleep. Similarly, for S-acylation, it acts as a molecular switch. So you have these S-acylases, which put these chemical capes on molecules, and that will take them to where they need to go to do their job. And then the deacylases take them off when the job is done. So this is a very important process. Not many people have heard of this process, even scientists, but it is so important because it happens to about 40% of the molecules that are involved in transmitting chemical signals in the brain. So it is very important to maintain the balance of this process, because we know that any dysregulation or any disruption of this process causes neurological diseases like Alzheimer's and Huntington's disease. So it is, because of its reversible nature, it is highly attractive as a drug target in the drug world. I'm particularly interested in the deacylase. There is this deacylase that has been discovered recently and has been flagged around the world to be involved in inflammation of the brain and, surprisingly, gastric cancer. And so in collaboration with some medicinal chemists from the University of Helsinki, who generated a series of drugs for me, I have tested all the drugs and identified 5 drugs that are selective and potent against this deacylase, which I will further take to try to understand its relevance to all the diseases and hopefully find a therapeutic target, a therapy for it. And so in future, if you hear any groundbreaking new drug that targets any neurological diseases or even cancer, I hope you'll be wondering if it's a drug against S-acylation. Thank you.
Good.